Hello everyone, today we are going to discuss and learn about my favorite topic in LRDI in CAT, which is the seating arrangement. And here we are going to discuss the introduction of it and also some of the basic concepts involved in seating arrangement, be it circular or linear, and also some of the tricky statements which you will encounter while solving questions of seating arrangement in CAT. Great, let's move on with the video. So here at first we are going to talk about the circular arrangements. Okay, so first we need to understand that if the question states that there are 8 people sitting in a circular arrangement, so by this line you are not going to assume that they are sitting like this: 1 2 3 4 5 6 7 8. No, assuming this will be completely wrong. Why? Because this is not a circular arrangement, this is just an array. At most it could be called a curve. This is not a circular arrangement. When we talk about circular arrangement, we are going to assume that they are sitting facing each other at equal intervals. So they are sitting facing each other at equal intervals. Okay? And how we are going to draw that? So basically, if the first person is sitting here, we assume that someone else will be sitting here facing towards them. In the same way, this side, then this. So there are 6 people by now, and by this we get 8. This is the first person, second, third, fourth, fifth, sixth, seventh, and 8th. So this is the right form of seating arrangement, while this is wrong. And once again, if you are given that 6 people are sitting in a circular arrangement, so you are going to draw them like this: 1 2 3 4 5 6. This is how the 6 people are sitting in a circular arrangement. Got it? Now you also need to understand that if you are asked that, see, because in a circular arrangement or any kind of seating arrangement, you're always said that, a person is sitting to their right or their left or in a clockwise direction or an anti-clockwise direction. So you need to understand that if every one of them is sitting facing inwards, okay, so if the arrow is this side inside the circle, this means they are sitting facing inwards. And if that is the case, their left, let's draw it from yellow. So if they are sitting like this, so their left is basically the clockwise direction and their right is the anti-clockwise direction. Okay, so if I say that the person sitting to the right, to the clockwise direction, we are 5, will be 6, right? So whenever we talk about this, if I am saying clockwise, I mean left if they are facing inwards, and if I say clockwise, anti-clockwise, and they are facing inwards, this means that I am talking about anti-clockwise. And of course, very obvious reasons, this entire statement changes if they are facing outwards. So what happens if facing inwards? Let's write it down. So for facing inwards, left equals to clockwise and right equals anti-clockwise, right? But on the same hand, facing outwards, left would be anti-clockwise and then right becomes clockwise. See, do not get confused in circular arrangement questions, especially when they are talking about inward and outward directions. At the same time, if they use the terms like clockwise and anti-clockwise, they are simple. All you have to do is assume yourself in their position and you will be able to understand how to go about it. Else, always remember that if facing inwards, left will be clockwise, right will be anti-clockwise. Facing outwards, left will be anti-clockwise and right will be clockwise. Great. Now let's look at some of the linear arrangement questions. So whenever we talk about the linear arrangement questions, we first of all, let's say we are assuming that they are all facing in this particular direction. Okay. So if they are facing, so there are 7 people. So there are 7 people and all of them are facing at a particular direction. So you see, if they are facing towards you, if the way you are looking and they are also looking is that this side, this becomes, then your right becomes their right and your left becomes their left. Okay, let's see how we are going to understand it better. Assume that this is the compass. Okay, so the way from where you are looking at will be the north direction, opposite to you is the south, the right hand becomes your east and the left becomes your west. So if everyone is facing north, we know that the right is east and the left is west, right? But if everyone is facing south, so if everyone facing south, then the right becomes your west and your left becomes east. Okay, this is a very easy diagram that you can draw also in your exams if you are having confusion on how to go about directions in linear arrangement questions. Okay, secondly, what next we need to understand is that if people are facing like this, okay, so if there are a group of 8 people who are facing each other, okay, so the statement is that there is a group of 8 people who are facing each other. This means that they are sitting in this arrangement: 1, 2, 3, 4, 1, 2, 3 and 4. Okay, so here as you can see that they are also facing north, these all are facing north and these all are facing north, let's write it with red, and these all are facing south. So all those who are facing north will have right on your right and left on your left. Okay, but on the other hand, all of those who are actually facing south will have the other thing, because they will have this side as their left, they will, and your right will be their left and their left will be your right. Got it? So this just interchanges. So it's in order to understand, if they are facing north, you can assume that they are sitting in the same direction you are, while if they are facing south, they are sitting on the opposite direction as you are. Okay, great. Now let's move on with the next part, which are some tricky points and their meaning. So now we are going to understand some of the tricky points and their meaning. Okay, so here first it states, if A and B, so if A and B interchange their positions, then each of them gets exactly one new neighbor. Okay, so if A and B interchange their position, then each of them gets exactly one new neighbor. First of all, it is important to understand that this is a linear arrangement problem. Okay, so this is a linear arrangement problem. Okay, great. Now let's draw 7 people for instance. Okay, so let's assume that there are around 7 people. So 1, 2, 3, 4, 5, 6, 7. Okay, and let's write the numbers for our convenience: 1, 2, 3, 4, 5, 6, 7. Okay, great. Now we need to understand that this statement states that if A and B interchange their position, then each of them gets exactly one new neighbor. So now we need to understand all the possible places that A and B can be placed. So I am going to define it as first ends and second as not ends. Okay, why I am doing this? Because ends are easy to identify and all of them are not ends, so it's very easy to understand. Okay, so assuming that if I put A here and B here, so right now their neighbor is A's neighbor is 2 and B's neighbor is 6. But if I interchange their position and I get A here and B here, now B's new neighbor is 2 and A's new neighbor is 6. So both of them got exactly one new neighbor. So I can place A and B. So I can place A and B at 1, 7 and 7, 1. So interchangeable is also possible. So with this we understand that I can place AB at ends. Okay. Now let's talk about when we are thinking of not ends. Okay, so when we are talking about in not ends, then where can we place A and B? Okay, so in not ends, then there are 2 ways I can place A and B, right? First here would be adjacent, right? If they are not at ends, then they might be adjacent. or they might be at gaps. Okay, so either they may be adjacent or either they may be at gaps. Okay, so if thinking of adjacents, let's see out all the positions that are available if they are placed adjacent. Okay, so let's have a look at it. So if I place A and B at 2 and 3, okay, so these are adjacent to each other. Right now A's neighbor is 1 and B's neighbor is 4, right? But if I switch it up and now I put B here and A here, now A's neighbor is 4 and B's neighbor is 1. Great. This means that 2 and 3 is possible. So if 2 and 3 is possible by that very same logic, so by that very same logic, if 2 and 3 is possible, then 3 and 4 is also possible, 4 and 5 is also possible, and 5 and 6 is also possible, and the opposite like 3, 2 is also possible, 4, 3 is also possible, and so on. But if we talk about gaps here, okay, so let's assume, okay, once again, that if A is placed at 2 and B is placed at 4. Now right now A has exactly 2 neighbors, 1 and 3, and B has neighbor 3 and 5. Now if I switch it up and I put B here and A here, now A has neighbors 3 and 5 and B has neighbors 1 and 3. Now 3 was the common neighbor at all times, so it is not technically a new neighbor. While B got a new neighbor which is 1 and A got a new neighbor which is 5. This means that I can place them at 1 gaps. Why? Because in that way, both of them will have exactly 1 new neighbor. Therefore, I can say that I can place A and B. I can place A and B at 2, 4, 3, 5, 4, 6, 4, 2 and so on. Got it? So this is exactly all about you can understand by this statement, and how it actually helps you in the examination is that when you have placed, okay, for example, in a statement, if here there are 7 people once again sitting, 1, 2, 3, 4, 5, 6, 7, and that 2, 4 positions have already gone, and 3, 5 position has already gone, and all the other combinations that you can think of has already gone. Then it is easy to understand that all the other combinations left will be the places where you can actually point out A and B. Okay, that is how it actually helps you in the examination. Understanding these statements reduces your time to understand the statement there and helps you solve the question more efficiently and accurately. Great. Now let's go to the next tricky statement. So here it states that number of persons to the left of A, it states number of persons to the left of A is equal to the number of persons to the right of B. Okay, let's once again draw 7 people. Okay, so 1, 2, 3, 4, 5, 6 and 7. Let's once again give them names, 1, 2, 3, 4, 5, 6 and 7. Now I have to understand where I can place A and B in such a way that the number of persons left to A will be equal to the number of persons to the right of B. Got it? So for instance, if I place A here, okay, and assuming that they are all facing in this direction as of now. So if I point out A here, so right now the number of persons to the left of A are 0, right? And if I place B here, then the number of persons to the right of B are also 0. Therefore, I can place A and B. So A and B, for them 1 and 7 is possible. But at the same time, 1 and 7 is clearly possible. But at the same time, if I point out and if I put A instead of that place, I put A here. Now it's to the right, there is 1. And if I put B here, for A to the left there is 1, and for B to the right there is also 1. This means 2 and 6 is also allowed. What about 3 and 5? Let's check it out. For 3, if I place A here, then to the left of it there are 2 people, and if I place B here, then to the right of it there are again 2 people. This means that 3 and 5 are also allowed. Consequently, I can also point it out as 7, 1, 6, 2 and 5, 3. I can't place 2 people on 4. Okay, so of course that is not a possibility with us. But there is one thing common if you actually have to, look at very clearly, that A and B, if I place at different positions and I know that the number of persons to the left of A should be equal to the number of persons to the right of B, then 1 plus 7, the number of the number at the places there are for A and B, their sum will be equals to the total number of positions plus 1. So 7 plus 1, 8. 2 and 6 is 8. 3 and 5 is 8. So is 7, 1 and 1, 6 and 2 and 5 and 3. So if I add them, I always get 8. Right? Now let's assume that you are in the middle of question. Okay, so you are in the middle of a question. Now in that scenario, let's say that there is A, B, again 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 and 7. Okay. And you know that these places, okay, so I will write 1, 2, 3, 4, 5, 6, 7 here. And if by the time I come to this statement, I have already filled for sure these positions. Okay, so there is J, there is Q and there is R. Okay, so now these positions are already filled. And now I get to the statement that the number of persons to the left of A is equal to the number of persons to the right of B. Now without any thinking, I know that whatever positions they are put on, their sum should be equals to 8. Now I know I cannot put them at 3 and 6 at the available position because that sums to 9. I can't put them at 7 and 6, neither at 7 and 3. But the combination that I've left with is 1 and 7. So understanding the more statements, I can put then A at 1 and 7 and B at 7 or vice versa. Right? But at the same time, I am narrowed down to so less choices and at a very fast pace. Why? Because I already understood what this statement is going to tell me. Okay? Great. Now let's move on to the next tricky statement. So here it states that the number of floors, so number of floors below B is equal to the number of floors above C. Okay. So once again, this is a very similar statement to the earlier one. So if I look at it, that there is, a building with 8 floors, assuming 1, 2, 3, 4, 5, 6, 7 and 8. Let's write down the numbers for a convenience. 1, 2, 3, 4, 5, 6, 7 and 8. Great. So all of these are floors. Now I know that if the statement is saying that the number of floors below B is equal to the number of floors above C and their total number of floors are 8, then B plus C's position should be equals to 9. Once again, this means I can place them at 1 and 8. So I can place B and C at 1 and 8, 2 and 7, 3 and 6, 4 and 5, and that's it. And of course I can just change vice versa also. So I can do that 8 and 1, 2, 7 and 2, 6 and 3 and 5 and 4. So once again the sum at all places is equals to 9. Okay, so all of them, they have the equal sum, which is 9. Great. Now the question is that if by the time again you come to this particular statement, you have already solved for some of the positions. Okay, so assuming that you have solved for P, Q, R, S, and you think that these all are correct. So assuming that you think that this part till you have solved is actually correct. But now you come to this part. Now you know that you cannot place B and C either at 8, 7, 6 and 5. So this 4 combination is not suitable for B and C, right? And if that is the case, then you cannot have the, you cannot solve the question according to this particular statement. And this means that you have done some mistake while solving the other statements. And if you wouldn't have done it, then you would have at least places to put B and C somewhere. But you don't have it, because here the sum will be 15, here the sum will be 11, here the sum will be 13. So this means that you have not been able to solve the question till PQRS correctly, and you should go back and verify your answer. Great. Now with this, we have come to the end of this video, and I am sure that all of you understood the basic concepts of seating arrangement and also some tricky points that you must remember while solving them. Now I would highly recommend to go and watch the other videos on EduRev, as well as have a look at the documents for you to understand them better. And if you are confident enough, you are always most welcome to go and solve the test on the EduRev platform. With this, we end this video, and I hope to see you in the next video. Till then, have a happy learning with EduRev.